C9301 4B2 কোনো নাম নেই। Good morning, everybody.
Good morning, ma'am.
Uh,
Good morning, ma'am.
so how are you? Fine or a bit scared?
Ma'am, bored হয়ে গেছি, bored.
It's difficult to have this kind of life. And the slides are available?
Yes, ma'am.
Yes.
And Oishi, is there anyone with C93014B2 code?
Ma'am, I asked them क्यों तो बोलना ना किचु.
So let's keep that person waiting.
Yes, ma'am.
First, I am starting with the numerical exercises which I gave on day before. Some people asked the values, so let me first tell you the values. Okay, so 1A, there were 4 numerical exercises. Can you remember?
Yes, ma'am.
Okay, so 1A, the answer is 5 by 3 root over 18 by 19, comma, root over 18 by 19. You need to solve the values of X and Y.
For 15 by 19.
In the last day, you asked me for the answers.
Yes.
Okay, so this will be the result.
ম্যাম কি বললেন আরেকবার বলুন?
একবার বলছি 5 by 3 root over 18 by 19. 18 by 19 under the root.
হ্যাঁ 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 ঠিক আছে। So root
comma,
50 by 90.
হ্যাঁ,
Yes.
comma root over 18 by 19.
Mhm.
Yes.
B, 7
Root
point
32.
B, second
হ্যাঁ,
problem, 7.38, 11.07. These are
হ্যাঁ,
the two
ওটা
values.
সি। না ওটা সি এর আনসার এসছে।
Yes. Yes.
C
Yes.
এর আচ্ছা আমি কি ঘুরিয়ে দিয়েছিলাম তো মনে নেই অঙ্কগুলো। C ছিল 3 4, তাহলে B টা কি 3 4?
না, বিটা root 5 by 2 আর root 6 by 2।
Root 5 by 2, root 6 by 2.
Right.
Root 5 by 2. So I have to check what will be the value. Root 5 by 2 and
root 6 by
Root
6
6
by
by
2।
2.
root 6 by 2. Okay, I'll check it. B and C is 3 4.
না, সি 7.3 11.06।
ও ওইটা বলছো তোমরা
Yes,
C তে
yes.
এসেছে। আচ্ছা
হ্যাঁ হ্যাঁ,
আচ্ছা, আর D একটা
10
5
11
0,
10, 10, 11.
10
10
11
11
10,
10
11.
11
হ্যাঁ
10 11
10 11,
হ্যাঁ,
5 0 minus 5 0 নয়।
না
No.
10 11।
না, না।
হ্যাঁ, ওটা তো মানে জাস্ট লিনিয়ার কনস্ট্যান্টটা তো পুরো সবই লিনিয়ার ছিল।
একটাই হ্যাঁ মানে
হ্যাঁ, তো
বুঝতে
তাই জন্য
10 11।
হুম
10 11।
আচ্ছা আমি আরেকবার একটু চেক করে তোমাদের কনফার্ম করে দেবো,
আচ্ছা, ঠিক আছে।
ঠিক আছে?
হুম।
কতক্ষণ
Okay. And then we are starting the constant optimization. Did you get time to check all these things or solve several exercises?
হুম। ম্যাম, এই আপনি যেটা লাস্ট প্রেজেন্টেশনটা পাঠিয়েছিলেন ওটার একটা ইয়ে দিয়েছিলেন, ওই ডিরাইভ দ্য স্ট্যাটিস্টিক ইকুয়েশন, শুধু ওটা পারিনি, বাকি অন্যটা পেরেছি।
Okay. And
yes
briefly, do I need to just tell the brief things we need to do in case of consumer theory? So it will be helpful if I summarize the matter.
হুম।
yes ma'am
yes
Okay, so let's first summarize the matter in the first half, then we will move for the numerical exercises. Okay.
ম্যাম দর্পক বলছে হি ইজ ইন দ্য ওয়েটিং রুম, আর সোমদুতিও ঢুকতে পারছে না।
Shomduti, I entered. Maybe at this moment she is facing some problem. Shomduti, I admitted. Okay.
ওকে
Again,
Oh.
she has some problem with the connection, and Dorpok has this peculiar number C93014B2.
প্রবাবলি ইয়েস ম্যাম।
So tell Dorpok to call me and confirm that it is he. After that, I'll.
ম্যাম এখানে তো সবার নাম্বার দেখাচ্ছে, কোথায় C9 কি বললেন
তুমি
নাম্বার
দেখতে পাবে না তো, আমি তো
ওটা
ওয়েটিং
waiting
রুমে
room এ আছে।
রেখে দিয়েছি।
ও আচ্ছা
There are several issues related to the security. Your class told me about this thing, so I enabled waiting room, everything, every security measures we need to protect ourselves. So I have taken all these things. So if Dorpok has this peculiar name or number, so let him confirm the thing, and then I'll admit him. So in the constant optimization technique, the two most important context is utility maximization, and with utility maximization, there comes a dual problem, which we call the expenditure minimization problem. And the second issue is output maximization and the dual problem cost minimization. Or you may consider cost minimization as the primal problem, then output maximization will be the dual problem. So these two important economic context are two important pillars in context of constraint optimization. So in these slides, I have summarized the first pillar, utility maximization, expenditure minimization. Then what will happen if we consider the indirect value functions, what possible results we can derive out of those indirect value functions, etc. And in the coming day, we will discuss about similar kind of thing in terms of production and cost. That will almost wrap up our entire syllabus for the constant optimization. After completing utility maximization vis-a-vis expenditure minimization, as well as output maximization vis-a-vis cost minimization, there will be 1-2 simple things that we need to cover. But these are the 2 important things. Just a minute. হ্যালো, হ্যাঁ দর্পক, হ্যাঁ তোমার নামটা আমি দেখতে পাইনি এখানে ওয়েটিং রুমে। তুমি কি নামে ঢুকছো? হ্যাঁ, দর্পক নামের কেউ ওয়েটিং এ নেই। না, দর্পক নামের কেউ ওয়েটিং এ নেই। একটা ওয়েটিং এ আছে, দ্যাটস দ্য নাম্বার, দ্যাটস নট আ নেম। তুমি তোমার নাম দিয়ে ঢোকো, আমি তোমাকে তখন নিয়ে নেব। হ্যাঁ, বিকজ দেয়ার আর সেভারাল রিজনস। তুমি আজকে তাহলে অন্য কোনো নাম টাম দিয়ে এন্টার করেছো? হ্যাঁ, তোমার নাম দেখা যাচ্ছে না গো। দর্পক চ্যাটার্জি নামের কেউ ওয়েটিং এ নেই। ওয়েটিং এ একজন রয়েছে, হি ইজ নট দর্পক চ্যাটার্জি, হি হ্যাজ আ পিকুলিয়ার নাম্বার। হ্যাঁ, একটা নাম্বার দিয়ে আছে। ওকে, তুমি সমস্তটা থেকে বেরিয়ে গিয়ে আবার তুমি ঢুকবার চেষ্টা করো দর্পক নাম দিয়ে, তখন আই উইল এন্টার। ঠিক আছে, আই উইল অ্যাডমিট ইউ দেন। হ্যাঁ 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 হ্যাঁ, please enter the way you enter regularly and then I'll admit only. Hello.
Yes, ma'am.
I think by this time Shomduti and others who tried to enter, I think all those people entered. Okay, so we are starting with utility maximization. So it's a simple exercise. You are aware of this entire thing. We have an objective function. So u is equal to f of x1, x2. We can extend always this kind of exercise up to n dimensions. But for simplicity, always we start with 2 variables. In this case, 2 commodities, quantities of 2 commodities, x1 and x2. You can consider 3, 4, 5, 6. Generally, at the undergraduate level, mostly we consider the 2 commodity case. So this is our objective function. Then I'm discussing several properties of the objective function. When we discuss the properties of the utility function, we mention about the slope, we mention about the curvature, etc. So the function f is continuous, has continuous first and second order partial derivatives. The function f is regular, strictly quasi-concave function, satisfying the condition f11 f2 square minus 2 f1 f2 f12 plus f22 f1 square, which is less than 0. I hope by this time you are quite familiar with the idea of quasi-concave. Actually, if a function is quasi-concave, its level curve will be a strictly convex curve. I hope you can remember in your first semester, you learned about the indifference curve, and the type of indifference curve in general we consider that is negatively sloped and strictly convex to the origin. So this quasi-concavity of f, that is the utility function, will ensure the strict convex curvature of the indifference curve. Partial derivatives of f are strictly positive, implying that consumer will always desire more of both commodities. Actually, the partial derivatives are nothing but del u by del x1 and del u by del x2 These indicate marginal utilities. So as you consume more of X1, marginal utility is positive out of that. It may increase at decreasing rate, which we call the diminishing marginal utility, but that is the second order derivative. If we consider the first order derivative, that is simply the marginal utility, not the change in marginal utility, that marginal utility is always positive. Any question regarding these three sub-points regarding the utility function? Next, from the utility function, we are moving to indifference curve. Indifference curve is a curve along which the utility level will remain fixed. So we are presenting indifference curve as U naught is equal to f of x1, x2, where U naught is the fixed level of utility. I hope you can remember along a particular indifference curve for different combinations of the two commodities, utility will remain constant. So this is the idea. Utility remains constant for different combinations of x1, x2 along an indifference curve. And from this equation, we can easily derive the slope of the indifference curve. And clearly, the slope is negative, or the absolute slope is positive, which is given by ratio of marginal utilities, which we also call the marginal rate of substitution. Next, from the indifference curve, we consider the curvature, that is d square x2 by dx1 square, which gives us the derivative minus 1 by f2 cube, f11 f2 square minus 2 f12 f1 f2 plus f22 f1 square. So here from f1 by f2, you need to derive this derivative. First order is f1 by f2. If you take derivative once again of this f1 by f2, you will get this expression as f2, which is the marginal utility of x2, is positive, and this expression is negative by the assumption of quasi-concavity. The entire thing becomes positive. Here there is a minus sign, f2 is positive, this term is negative, so this entire thing is positive, which ensure the strict convexity of the indifference curve. This has other implications too in terms of utility theory. Here is the sentence. The negative slope of the IC becomes larger algebraically and smaller in absolute value as x1 is substituted for x2. As a consumer moves along the IC, the person requests more x1 and less x2, and the rate at which the person is willing to sacrifice x2 to acquire more x1, that declines, which we call diminishing marginal rate of substitution. So simply, as we are moving along the indifference curve, the slope is becoming flatter and flatter. The slope, negative slope, is becoming lesser and lesser, which means the slope increases in absolute term because negative slope is continuously flattening. So that is the idea. So negative slope of the IC becomes larger algebraically and smaller in absolute value as x1 is substituted for x2 as the consumer moves along the IC. So this is the idea when we are considering quasi-concavity of the utility function or strict convexity of the level curve. It is related to the idea of diminishing marginal utility, diminishing marginal utility. MRS is declining throughout as you are substituting x2 continuously. by x1. You need more and more of x1 to leave a very small amount of x2. So that is the thing. In the beginning, you said that, with the lockdown, you were bored. When there is a regular class, we feel that, when we will get some leave. But now, so too many leave, you know, is providing diminishing marginal utility of this kind of vacation. So all these things happens in terms of commodities too. So this is the idea when we are considering the second order derivative and indicating utility function is quasi-concave, or we are mentioning that its corresponding level curve is strictly convex, etc. Any question regarding the slope and the curvature of the indifference curve? Is it okay?
Yes.
Yes, ma'am.
Yes, ma'am.
And I'll request all of you, I think many of you did this derivative, etc. But I also know some people didn't get time, somehow could not manage to derive all these things. You have to complete all these exercises because you will not remember all these things. You will do always the derivatives, etc. on your own. So please practice all these things and derive all these results. Next, with these properties of the utility function and the properties of the corresponding level curve, that is the indifference curve, next, we consider utility maximization exercise. That is, along the indifference curve, we will like to find out the best possible combination of x1 and x2. Best possible combination means which will maximize the utility of the individual. Now, individual can find out the best response or best possibility only subject to the income constraint. So we are considering the income constraint m is equal to p1x1 plus p2x2. I mentioned earlier in this section we are considering only the equality constraint because already the inequality constraint has been handled. So here we are considering m is equal to p1x1 plus p2x2, and there were some other parts where you learned about how to handle the inequality constraint. Now, in case of equality constraint, Lagrange derived a wonderful formula where the objective function can algebraically be added with the restriction or with the constant using a Lagrange multiplier. So here we are writing the new objective function where we are adding the original objective function with the constraint along with the Lagrange multiplier. So the new objective function is z is equal to f of x1, x2, original objective function, plus lambda m minus p1 x1 minus p2 x2. Earlier also I mentioned, I'm repeating once again, if you consider minus lambda, you have to consider the constraint as p1 x1 plus p2 x2 minus m. Next, we consider the first order derivatives, z1 del z by del x1, which is giving f1 is equal to lambda p1, z2 del z by del x2, which is giving f2 is equal to lambda p2, and z lambda, which is giving back the constraint itself, that is m is equal to p1 x1 plus p2 x2. We have to solve only the two variables x1 and x2. We want to find out x1 star and x2 star. However, we have three equations. So what we do, we combine equation 1 and 2, considering the ratio f1 by f2 is equal to p1 by p2. f1 by f2 is the absolute slope of the indifference curve, where P1 by P2 is the absolute slope of the budget line. So from this budget line, if we present P2x2 is equal to m minus p1 x1. In the next step, x2 is equal to m by p2 minus p1 by p2 x1 by x1. In that case, the absolute slope of the budget line becomes p1 by p2. So we are deriving a new equation, marginal ratio of marginal utilities, or MRS x1 x2 is equal to relative prices. According to the micro theory, this is the equation to the income consumption curve or the angel curve. So we started with a strictly convex level curve and a budget line. However, using the Lagrangian expression and using the first order conditions, we are now concentrating on two straight lines. One is given by the equation to the income consumption curve or the angel curve, and another one is the equation 3, which is the budget line. Solving these two equations, that is the budget line as well as the ICC, we get the optimum values of x1 and x2 given by x1 star and x2 star. x1 star and x2 star are the functions of p1, p2, and m. The way we derive the demand curve is called the ordinary or the Marshallian demands. So these two demands, x1 star and x2 star, are functions of p1, p2, and m, and these are the ordinary or Marshallian demand. The next step will be to ensure whether x1 star and x2 star are really maximum or really providing the maximum utility. So to do this, we need to check the second order sufficient condition. So this is the necessary part to solve for x1 star and x2 star. Once we get these two values, we need to check whether these two values can gives us max u star. So to understand this, in the next step, we are considering the bordered Hessian determinant. By this time, you are quite aware of the bordered Hessian determinant. Last day, we discussed about three definitions of concavity, three definitions of convexity, etc., etc. So one in terms of graphical presentation, another in terms of the Hessian determinant, and the third one was in terms of the bordered Hessian determinant. Now, the strict quasi-concavity of the utility function, which we considered as f11 p2 square minus 2p1 p2 f12 plus f22 p1 squared less than 0, or in terms of f11 etc. This exercise, this thing, or better to say this expression. Okay, this expression we need to be less than 0. Now, if we need this expression to be less than 0, that is, if we need strict quasi-concavity, in that case, this bordered Hessian should be positive. Can you remember that?
Yes, ma'am.
So we did all these things as the background work. So for maximization,
Yes, ma'am.
maximization, that is for strict quasi-concavity or strict convexity of the curve, level curve, we need the bordered Hessian determinant should be greater than 0. So that we are mentioning. Then we are finding the values for z lambda lambda, z lambda 1, z lambda 2, etc. To understand this, let's go back to the first order condition. So we are considering z11. If you consider z11, what value you will get?
F11.
Del square z by del x1 square gives us f11. Del square z by del x1 x2, that is z12. What is the value? f12. Everybody?
Yes.
Del square z by del z lambda lambda, that is, if we consider this value, what will be the value? Del square Z
0.
by del
0.
lambda square? 0.
0.
Okay. And
0.
from Z1 and
0.
Z2, yes. If I take derivative with respect to lambda, we will get back minus P1 minus P2. That is Z1 lambda, Z2 lambda. This will be minus P1 minus P2, etc. So we are putting these values here. This is Z lambda lambda. This is Z lambda 1, which is equal to Z1 lambda. This is Z lambda 2, which is equal to Z2 lambda. Z11, you told will be F11. Z12, you told it will be F12. Z21, it is F21. And remember, this F12 is exactly equal to F21. Z22 is giving the value F22. So this expression should be positive. And if you solve for this thing, you will get exactly this value. Okay, so you have to complete this thing. Please solve this determinant and you will get this expression. So this value, positive value of the bordered Hessian determinant will ensure quasi-concavity of the utility function, and this will in turn ensure the level curve is strictly convex, and that ensures the value we are getting, that is a maximum, because for the maximum we need convex curve, convex level curve. Any question? The first order conditions you did in your micro classes in the earlier semester. The new thing we are learning here is to understand the quasi-concavity of the function, convexity of the level curve, and how these things are related to the issue of Hessian determinant or bordered Hessian determinant. If it is unconstant optimization, this entire discussion centers around the Hessian determinant. And if it is the constraint optimization, the second order condition centers around bordered Hessian determinant. However, the basic idea is same between the two things. Any question? Next, interpretation of Lagrange multiplier. You will find that after doing all exercises, that is after completing utility maximization, we are trying to interpret Lagrange multiplier. After completing expenditure minimization, again we will try to understand what is the meaning of Lagrange multiplier in this case. Then when we handle the indirect value function, then also we try to understand what is the meaning of Lagrange multiplier. So if we consider the whole set of utility maximization, expenditure minimization, along with the indirect value function approach, we will interpret lambda 4 times. One with utility maximization, another with expenditure minimization. Then when we will use the indirect value function for utility and for expenditure. So all these things will come together. Now, if you look at the first order conditions, the interpretation of the Lagrange multiplier or the value of the Lagrange multiplier is coming as F1, that is marginal utility divided by price. So it is marginal utility of the commodity deflated by price, as if it is the marginal utility of your expenditure. That is, you have some marginal utility and that you want to derive in real terms. Therefore, you are deflating it by the price. So I'm repeating, you are enjoying some satisfaction from the commodity when you are deflating it by the price of the commodity. You are trying to find out net utility, net marginal utility out of consumption of the commodity. In other words, you are trying to find out money value of your satisfaction. In that sense, we call lambda here the marginal utility of income, marginal utility of the money we are spending. Here, M has been treated as our income because the constant is M is equal to P1x1 plus P2x2. That is, we are spreading our income in consumption of two commodities. Therefore, when we are considering the marginal utility in terms of monetary terms, so that is nothing but marginal utility of the income I'm spending on a particular commodity. So it is some kind of quantification of our satisfaction. So in this context, that is when we discuss the ordinary demand curve or the Marshallian demand curve, the lambda is interpreted as marginal utility of income. So I have roughly, 1 minute to complete this session. So if any question, any quick question, then again we have to re-enter. And you look at the last sentence, since marginal utilities of the commodities are assumed to be positive, marginal utility of income is also positive. Any question?
No.
So rest of the students, it's fine to everybody?
Yes,
If
ma'am. So far.
anyone
Yes,
have
ma'am.
any question, please think about this. And next, we will consider several properties of this ordinary demand function. We will discuss some elements related to this ordinary demand function. So derivation of the ordinary demand function, that is complete. This is an extension of the same thing. So by this time, you check these conditions and try to understand how we are getting ultimately the n equations. First, we will get n plus 1 equations, because n equation in terms of n first order conditions for n commodities, and then the income constant